Welcome to the first video on arrays, and I'm going to give you some sample programs that illustrate how arrays work. Our first program I call Motivation, and you can see it's called Motivation 1. There'll be a 2, 3, and 4 as we progress. But first off, why do we need arrays? Up to this point, all our code was dealing with simple variables that hold only one value. And so what I would like to do is say, well, pretend we don't know arrays, and officially we don't know arrays. We haven't talked about it yet. I would like to write a program that reads in three numbers and determines what the largest, it prints out all the values that are greater than the average of those numbers. Okay, so we read in three numbers, calculate the average, and print the ones that are bigger than the average. This code does it. Okay, this reads the first three numbers with next doubles. We read the first number to A1, A2, A3. We calculate the average, so that's how you calculate the average. Sum them up divided by 3. And then we have to have some if statements that go ahead and say, well, if A1 is bigger than the average, print it. A2 is bigger than the average, then print that. A3 is bigger than the average, print that. Okay, it works. Now the question I have is this. What do you do if you would like to do the same basic algorithm but with 100 numbers? Are you going to define A4, A5, A6, A7, A8, etc. all the way up to A100? And then have 100 next double lines? And then we're going to have a bigger averaging method here, and then we have to have 100 of these if statements. You can see right off the bat, that gets old real quick. And that's not the way to do it. So, this is the kind of, first off, let me just prove that this works. I suppose we should take a look at it and say, hey, does it work? Come on, I'm running it. It's a little slow. This machine is slow. Going on here? Where's my output window? Window, appearance, view, console. Oh, the problem is I didn't have any output. Sorry about that. Okay, I'm gonna enter 10, 20, and 30, and if the only number that should be printed out is 30, right? There you go, because the average would be 20, and all the numbers bigger than 20 gets printed. Okay, great. Let's come over here and get rid of this window, and then come over here and reconstitute. Let's get rid of this console. Boy, we got problems all over the place here with this Eclipse, huh? Let's take a Motivation 2. Motivation 2. Let's do a better version. Now, this is Motivation 2. This is the start of our array simulation. Okay, this is the first thing that we're going to do to create a problem, to do this problem. What we're going to do is define an array of doubles. This is what it does here. New, doubles, I want 3 of them. That's how you define an array. That array gets assigned into a variable called x, and that x has to be defined to be an array of doubles. So whether you put the parentheses in the front in the definition or in the back, front or the back, it basically does the same thing. X is defined to be an array of doubles, and I prefer to have it this way here. It looks better to me. So basically what you have is you've created space for 3 values. Those values are indexed using the name x, or accessed using the name x, and you need an index to locate the individual element you would like to manipulate. This is what we're doing with the for loop. For loops. For I equals 0, I is less than 3, I plus plus. What does that do? That generates an I that's 0, 1, and 2, not 3. And so x of 0, this is the subscript, 0. X of 0 is equal to whatever I type in. X of 1 will be whatever I type in for the next number. X of 2, next number. Now what I'm going to do next is go ahead and say, well, I'd like to define, do the average. Now, how do I do the average? Basically, what I do now is I have to say, well, sum up all the numbers. Okay, start with 0. And then basically, I did a little shorthand there. Sum plus x of I. Okay, this is how I add up all the numbers that are in my array. Another for loop. 0, 1, 2 are my indices. X of 0. Add that to sum, which is 0. The sum is x of 0. X of 1. Add that to x to the sum. It's the sum of the two numbers. Assign it to sum. X of 2 gets added to the sum. We accumulate the sum. And then what we're going to do next is divide that sum by 3. And instead of having 3 if statements, I go through my array again and say if x of 0 is bigger than the average, print it. If x of 1 is bigger than the average, we print it, etc. This works great. If I said, well, what do you do if it's 100 numbers? I change the storage to be 100. Okay, new double of 100. That creates an array of 100 elements, 100 storage locations indexed from 0 to 99. Very important. If this defines the amount of storage you want, the number of doubles, number of ints. This was int. Okay, I'm going to do doubles though. New double, 100. The first index is 0. The last index is always 1 less than the space you want, 99 in this case. Remember, 0 counts as an element, so 0 through 99 is 100 indices. Now, but the problem now is I have to go through and change all my 3's to hundreds, and that could be a little bit error prone because you might forget a 3, or there might be another 3 that has another meaning. Okay, but this is the problem here. If I change this storage to make the algorithm will work with bigger storage, but I have to go through and change all my 3's to hundreds. Now, there's a better way of doing this. This is the main 2, my second version here, where instead of hard coding this 100 into my code, there's a property or an attribute that every array has, and that's called the length attribute. If you define an array of 3 elements, the length of the array is automatically associated with that element, and you're automatically going to have a 3 attached to that array. There's a field automatically given to every array called the length field that specifies how many numbers are in the array. So, notice what I'm doing now. Same code. We don't need to go over it again. Same code, but this time I'm tying my logic to x.length. And the nice thing about that is if I change that 3 to 100, I don't have to change anything else. I have basically the same code, and it adapts quickly to the problem. If I wanted 1,000, so be it. I read 1,000. I'm not going to type in 1,000 numbers, but the algorithm will work great. Now, the next motivation is, well, the problem with these other programs I showed you here is you got to use methods. Okay, this is not acceptable coding here. That's not acceptable coding. The main method has to be short and sweet. It should drive the logic. It should basically pass data around. And this is what I'm trying to show you with the motivation 3. So all these motivations basically do the same thing, but hopefully we step one by little by little to the perfect program. Okay, so what I'm going to do here is take a look and say, well, that's a pretty nice small main method. It describes what we're trying to do here. All right, we have a scanner that we need to define. We're going to close it at the end. You generally have to create your scanners in your main method. And if you have a method that requires reading a scanner, you have to pass that into the method. So init array will take that open scanner and return an array of numbers. That's it. From the point of view of this main method, I don't care how this init array does it. It's going to take that scanner and return an array of numbers. We'll leave it at that. Now that array of numbers gets passed to the calculate average. Have it return the average. Then once we're done, what we're going to do is pass that array to another method called report on larger than average. See, that just describes what it does. Pass it the array, pass it the average, and hopefully you print out the numbers properly, and we're done with the logic of the main program. Take a look at init array. Init array. takes in an open scanner. Okay, this is hard coded to be 3 elements because I'm not going to type in a bunch of elements here. I'm going to show you different programs that will allow you to input different more elements than 3, but this will suffice. Here we create our array, and what we're going to do is for every element in that array you're going to read a number, and basically what you should be getting out of this is that arrays are great. That defines the storage. A for loop is what's used to always manipulate the elements in that array. So they work hand in hand. So whenever I type in, the first number goes into the 0th element, the second number is in the first element, whatever. Then we're done. We return that X. We return the array. So that array gets returned, and then it gets passed along to here. Calculate the average, sum up the values, then divide by the length, and then report on the larger than average. Take a look at this. We pass it the array and the average, and then we write our code based on these values here. For I is equal to 0, I is less than x of dot length, I plus 1. That says basically visit every element of that array. If that element's bigger than the average, print it out. Perfect. See, when you're dealing with methods, the methods will try to write the methods so that it reads the parameters. That's the data that you passed into that method. Okay. Now let's see how we can improve it. I do want to mention one thing, is that there's 2 ways you could have handled this problem of initializing the array. See, from the point of view of the main method, this method here is expecting an array that's been created internally. Another way to do this is to do it this way. Okay, let me just comment that out. I'm going to call this init array 2, so there's no confusion here. What we're going to do is pass it the init, and then what I'm going to do is pass it an already created array. Let's say x. Okay, and so what I mean by that is, see, in the first version, the method creates the data and then returns it. In array 2, I need to create the data in the main method and pass it to the second version, so that x is an array equals new integer array of 3. Okay, and so init 2 needs to be defined, and let me define it let me just have the program define a quick fix, create the method. And basically it's defined like this. Alright, and so let's see, why do I have an error here? Calculate the average. Oh, because it's double. I should have made it double. Sorry about that. Double, and this should be double. And this should be double. Okay, so we fixed those errors there. So the first version, the array gets created internal to the method and gets returned. The second version is you create the array in the main method and then you pass it to init array 2. You'll notice that init array 2 doesn't return anything. It's a void method. It doesn't return anything. But I pass it that already created data array to the method, and then I can go ahead and simply copy this code, copy this, and paste it in here. And basically our job for initialization is the same, only it's where you create the array. If you created X, in the main method, you have to pass it in as a parameter to initialize it. Or you could have init array create the array itself and initialize it and return it. Personally, I like the first version. So this guy here, this is nice. It's used by some people, but what I would do is just delete it get rid of it. We're not going to use that technique. I'm going to have the method actually define it. I just felt I needed to show you that. And that's, now we're back to the original program there. So the fourth version is looks like it's the same. It's the same. I think. Oh, that was the fourth version. For 4B. What I'm going to do is stop the video here for 4B, because what I'm going to do here is say, well, I would like to read in 1,000 numbers. Okay, I'm not going to type in 1,000 numbers. All right, I'm going to show you how you do have the ability to read 1,000 numbers, and I'm going to show you how to read a file. Okay, so we'll do that in the next video.